Good evening, everyone, and welcome to the first developer user group meetup of 2022. Hopefully 2022 will be a lot better than the previous 2 years, but for now we will still be doing these online. Today we've got two, from what I've seen, quite amazing speakers. Both of them have been working with computers since before some of you were even born. Firstly, we've got Maia coming up. As in her own words, she's been using computers since there was no internet, which I can't remember a time like that. And she will be giving us a little intro into Jetpack Compose and a live coding session as well. Fingers crossed it will go well. Secondly, we will have Thomas, who has been working with computers since the early 1980s, which was actually before I was born, to be honest. And he says he fell in love with Android back in 2009. And he will be following on from Maia's talk, telling us what's new in Compose 1.1, and telling us a little bit more about all the Android fun things. Firstly, before we start, just thank you to Intellect for sponsoring this channel. When the meetups were still in person, there was also pizza. Unfortunately, I can probably send you a virtual pizza, but for now, hopefully you've got your own pizza at home. Order something quickly before this is over. We'll be here for about an hour and a half. After the talks, there'll be a 30-minute session where we will I think Maya and Thomas will take questions. Hopefully it will be a bit interactive, and then we can go from there. Also, something special this time, Offers has decided to give us a bit of swag. I'll send you the link after the two talks have happened, so you're not clicking away while they're talking and reading random things. And Offers has also sent out the State of the South African Developer Nation 2022 report, which is great to know exactly where you stand as a developer. Anyway, off to you, Maya. Enough of that marketing. Take it away.
Okay, sound check. While I busy start sharing my screen, what I'm going to do is I'm going to share my screen, and then if you can't see it, then you tell me. Don't tell me if you can see it. Tell me if you can't see it. Okay, so without further ado, I am Maia Grotepass. I'm an Android engineer and I work at Luno. And the talk tonight is Jetpack Compose, some broad strokes. It's the new declarative UI framework from Google. And I'm just going to give you a little taster so you can get an idea of what it's all about. So everybody has a phone. All of you have phones, I'm assuming. And if you're thinking about a phone, if you're looking at a phone, the thing to notice is there's this UI interface, and there's some other state that's coming either from the internet or from a local database that's been locally cached. And this state is what's coming up on the screen. And then the user has interaction, like the clicks on the screen. So there's some actions coming in from this side. And so there's state that updates the UI, and then there's events that get clicked through and click back up, and that can change the state again. For instance, if you click on the cupcake, it changes the screen state, and you might click on a donut or the pretzels, and it'll change the screen states. So this is just a little bit of background, and this is the thing. This is the same concept for web, for iOS, for Android, for everybody. So the next slide. So if you look at Android architecture, typically what it looks like is you have maybe one or many activities, you have maybe one or many fragments. And then if you're following the Android architecture patterns, you'll have possibly a view model with some live data or some other form of observable that's talking to the fragment. And then in Android world, you might have some repositories where the state, this cupcake represents the state, is going to be put into a repository. The view model sees that, and it comes to the fragment. Now, how does this get onto the screen? How do you get that onto the UI? Well, in Android world, we have this layout XML, and the layout XML says what the screen's going to look like. And so now where in this picture does Compose fit in? Now let's see if the animations work on Zoom if I click. So the idea is that Compose replaces this part there where the XML is. You still have a fragment in a view model, and you still interact with Compose in a similar way. It just replaces, instead of having XML to say what your screen's going to look like, you have code now. So let's just do a side-by-side comparison. Let's see what it was like in the old view system in Android. So I said there were XML files. The XML files said what you had. Maybe you had images or buttons on your screen. And these XML files, at some point when your fragment got started up, these XML files would be inflated, and it would build a hierarchy of objects that represent the whole of your view hierarchy. Whether the views are visible or not, it would take up memory and it would build a whole hierarchy of views. And then if you wanted to put some state into the view, you'd have to find the view, either by find view by ID, or there are other mechanisms as well, data binding or view binding. And then once you found the view, say it was called button, you could set the state on it, which means that you would like individually interact with these views and then set their state on them. Also, if you wanted to get some events back from these views, you would set the click handler. So if you look at this, there's a hierarchy of views and you're actually individually setting things on these views. Now, if I'm comparing this to Compose, this whole object tree is replaced by a hierarchy of functions. So there's an outside the uppermost function with some functions on the inside. And since this is code, this function tree doesn't get built initially. Like if some of the views are not visible or some of the pieces of the UI are not visible, then it just doesn't call the particular ones. It just calls the functions that it needs. The other thing to notice is that this function, the state gets passed into the function and the interaction handlers get passed in. So rather than finding views and particularly setting things on it in multiple places, this can be quite error prone because maybe you're setting an error message, but you forget to set an icon or something. Over here, the whole state comes in and the state gets propagated to the composables that need it. And then there's the concept of recomposition. So apart from this tree of functions, there's something that will recompose these functions. Recompose just means it will call these functions again, which will then emit the UI. So now let's just dive a little bit deeper into Compose. So if we've got this, there's a function that calls another function, calls another function, calls another function. So this is all Kotlin code. The view model gets passed in, or there's a thing called remember where you can set the state and get the state passed in. So how does this actually work? How do you write this in code? So the first thing you do is you put an annotation at composable, and then it's just an ordinary Kotlin function. You can call it whatever you want. Typically that needs to be a capital letter. And then you pass the state and the interaction handlers in. Now this at composable annotation, it's not really something that goes through the annotation processor. It's actually a compiler plugin. And what this at composable compiler plugin does, it passes in a secret parameter here in the parameters of this function. I hope you guys can see my cursor because I'm pointing. So it passes in the composer over here, and the composer is some code that will know about the state. So the composer has a slot table. The composer knows about state. It knows about the state of all the pieces, and it knows when the state changes. So the composer can decide which of these methods it's going to recompose or recall or redraw so that it can emit the UI. So you see here that it says unit. So it's actually not making a view. It's emitting UI, and that this composer hooks to the view system and makes the UI appear. Okay, let me take a breath. So now you can see we have to think about UI differently. We used to have a tree of objects, now we have functions. So, and we have this composer in the mix now. So it changes the way we think. So what are the things that you need to pay attention to? Well, first of all, it's all in Kotlin. There's no more XML. We have these nested functions, and the way it works is it's declarative. So what you say is, I want a picture over here. It's not imperative. You basically just declare how you want the UI to be. And the other thing to notice is you should not have any side effects inside these composable functions. So the state flows in and flows down, and then here, this cupcake state will get represented on a view somewhere inside the nesting. And the same way the click handler gets passed in, and then when the user clicks, it calls a click handler outside of this tree. And the state, once it comes in, is immutable. So why do we need to have no side effects? Well, the thing is, there's this composer, and the composer can decide to call any of these functions. It can call them in any order because it knows when things change. It knows when the state changes, or when, even if it's just a piece of state that changes at the bottom, it might not call any of the others. It might just call the one where the state has changed. Also, there are some optimizations that can happen. These composables might be called in parallel. It might decide to skip some of them. It might decide to cancel midway. And if there's an animation happening, the recomposition could happen quite frequently because the state is changing with the animation. So you can see, if you set a variable somewhere here and expect things to be called in a certain sequence, you can't rely on that. And that is the reason why you shouldn't be having side effects inside your composable functions. So now I'm going to go show me the code. So to do that, I need to stop share. Ah, good, you're all still there. That makes me happy. And we're going to jump into Android Studio and share that, and then we'll see.
Maya,
Yes.
you do have a question if you'd like to
Yes,
answer
hit
that
me
now.
with a
Or do you...
question. Okay. I can't see the
Cool.
chat, but tell me a question. Ask me the question.
Cool. So there's a question from Gondai. Is there a scenario where Compose can actually replace completely the fragment?
Yes, if you put compose inside the activity, then you don't have a fragment at all. So how that would work is you have a compose, you have one activity at the top because you need like a source activity at the root. And then if the state that comes in from, say, your view model or somewhere changes what the UI looks like, you can switch the UI to be anything you want, and you might not have any fragments in there at all. Does that make sense?
Makes sense to me.
Yeah, I can't see people's faces, but we can talk about it after some more, a little bit. In fact, my example here has no fragments, so that might be useful. Okay, so to jump into the code, I've prepared a little hello world. I'll give a link to a repo, so you can see that afterwards if you want, but it's really just a basic. I literally just took the wizard and made a hello world app. And the other thing I have to say is last night when I checked this out and tried this, my preview made my Android Studio crash. I literally had 6 crashes in 2 hours. So that might happen. So if everything freezes and nothing works, I might need to restart Android Studio or stop the preview or open up the emulator, but let's see how it goes. So first of all, for people who've been coding Android, you might recognize there's main activity. It's a component activity. So this is an entry point that we all know and love as Android developers. Here we have on create. And now instead of inflating any XML, we've got the set content function here. So the thing with Compose is you need to be, if you're outside of the Compose world, you need to have a way of getting into the Compose world, because in the Compose world, you can use the @composable annotation. So this set content basically will take you into the composable world, and it takes, look, you can see there, it takes a content, which is why we've got it as a curly brace annotation like that, or not annotation, but code like that. And so here there's a theme. I'm not going to go into the themes, but that's how the theme for your app in Compose is just a composable. So we don't go anywhere near XML. This is also Kotlin. And now here I have a composable, which is my main screen. And in my main screen, there's the customary hello world, which you need if you have a sample app. Now, if we're looking at this main screen, okay, yeah, so the next thing I want to show you is that we know now this activity, but we don't need to run an emulator to see what's going on. So there's this @preview annotation. And what this will do is there's my default preview. And this hello compose theme here looks exactly like this. And it's actually emitting this main screen over here. And I can see that it's hello world. Now there's other things you can do with preview. You can decide if it's night mode or not. You can set background color. You can give it a name. So all sorts of configuration options around the preview. So that's just to see what we're doing. So now, what does main screen look like? So main screen is a composable function. There's our composable annotation, which gives us some information about composable, and it's a function. I've got a surface, because surface in the material theming world gives you this white surface, and all I've got here is text, hello world. So if I change this to hello Ezra, you can see what I've got here is that it updates immediately. Doesn't work for everything. If you change some things, you still need to rebuild. But if it's just a text that you change like that, you're going to get quicker turnaround time on your visuals. So now let's try and do something else. So first of all, the text, the other thing to notice here is that there are some defaults. Text has more parameters. Let's just go Command P. And you can see, you can do lots of things with text, but you don't need to because the defaults are set so that all you really need to do is just give it a text parameter. So now here I've got a little bit of a list of things that I thought would be good to do. Some text with modifiers, some columns, some samples. Okay, so now the organizers of this, I'm just going to code. And if it looks like I'm hitting my 30-minute mark, or you get questions, then just interrupt me. So the first thing we've got here, so let's see, let's make a new composable. We've got a composable function greeting and it takes a name. So let's see if we can change that. So let's do this. Greeting, and we change the name to be Spot. Previous out of date, bold refresh, and we should get this greeting composable appearing on the screen. Eventually, one day, when Gradle finishes building. Okay, I think this bar at the bottom means it's rendering. Yes, right. Hello, Spot. So now let's see. I'm going to copy this, have a look at this greeting, and we can see what it's doing. So greeting takes a state, in this case, the name. It's just a text. There we're setting this with the way that you can make strings in Kotlin. And now here's the first concept that's interesting. All of the composables have this thing called a modifier. And a modifier is something that you can do, it's something that you can pass that modifies this text. So what we could possibly do here is we could do something like this. Background color dot red. Do we have a color red? We want the compose one, that one. And background, we need to import. And now the previous out of date, and we can update. So what am I expecting to happen here? I'm expecting the background to go red. The background goes red. But now do you see the interesting thing here is the padding, it did the padding before the background. So the thing to note with these modifiers is this order, it executes this in this order. So it'll do the padding first and then the background. If we switch this around and we put this over there, you'll see after we build and refresh, what are we expecting now? We're expecting to have full red background and the padding applied afterwards. And indeed, that's what happened. Okay, let's see what our next piece of code is. So what I've got here is a composable, let's call it label list. So this is just one word in a list, and it takes a label string, and inside it's just got a text. It's the same as this greeting, it's just a label list like that. And now the next composable here is the sample list. Now I've made us some sample words, and now instead of having this greeting in here, let's put the sample list in here. So I'm going to, instead of calling greeting, I'm going to call sample list. Let's see, which is the other composable I have. Preview out of date, build, refresh. While that builds and refresh, let's look at what it does. We've got this label, and now here, so here we're getting in a list of entries. I've got some canned data over here, and there we have it. We have all of these words coming in. And so this is a list, and all that it does here is it makes a column. So a column will put these words one after the other like that. And it just literally loops through the entries one by one and calls this label list, which then emits a text. So what you can see here is the way that you can build up the UI using code. So you can actually transform your data and use code to do this. But now we have a problem, right? Because I know the sample words are huge, but we can't scroll. So we can't scroll because it just filled it up to the bottom. And the good thing about Compose now is it won't recompose things that aren't visible. So now, how would we do now? In the old Android land, you would do a recycler view with an adapter and view holders and all sorts of other things. So now I'm going to what I'm going to do is I'm going to replace it with this guy, sample lazy. Oops, if I do that, Control Z, I'm going to replace my lazy list with sample lazy list. Where are we here? Sample list, sample lazy list. So while that's building and refreshing, let's look at the code. So what we have here, instead of a column, you see there's a column. Instead of a column, we have a lazy column. Okay, we still have our entries coming in, but we tell it what the size is, and then we've got this index, and then we run through the entries with the index like this. And the lazy column will take hold of this and know which pieces it needs to. It knows from, depending on the size, it's going to pass in the index, the right one, so you can get it. And so this should be scrollable now. Is it? Oh no, I have to. Good thing to know. So if you just preview it, you just see visually what it is. But if you want to interact with it, with a preview, there's the start interactive mode, which you can click over here. It starts interactive mode. Then you should be able to scroll. Okay, so you can see here, to build something equivalent of a recycler view is as easy as wrapping your code inside a lazy column like that. So at this point, if the mic was on, I would hear gasps of amazement, claps, and people fainting with delight, because this is such an awesome feature. Okay, now let's move on to something more interesting. So what I've got here is the sample card. Let's see, I can't use it directly like that. So what I want to do is I want to build a little card. So this card, let's see, this card is part of the material design cards. It's going to give me a card, and inside the card, I'm going to have a row with an image and then a column. So this is a typical like a little contact card with a picture and some text going through it. So let's see, let's just put the sample card into my sample place, and then we can see what it looks like and go through the code. So I'm just going to drop that in here, and then I'm going to comment and format so we can read it. So there's my sample card, and I'm passing in some text and some text. Build and refresh. Let's look at what that code looks like. So the sample card is a little bit more complex. So it takes a title, it has a short description and a long description. It's got this flag to know if we're expanded or if we're not. I want to stop interactive mode. So it's got this flag, and I want you to see here, this by here, this by is, it works by delegates. So it's going to say the remember has to give the value of the expanded, and it's a var, so you can set it. So you can set it and clear it to remember if it's in expanded mode or if it's not in expanded mode. So remember I said we wanted an image and then we wanted a column. So we wanted a row. So we're building up a row with an image and then a column with the text inside the column. So this expand is going to, and this remember, well, first of all, there's this mutable state is a state wrapper, which is going to wrap around a Boolean value. We're setting it to false, so it starts in unexpanded mode. And the state, then we're telling Compose to remember the state inside the slot table with this remember function. So this means that the composer is going to keep track of the state and then decide if it needs to recompose the image. So if this value changes from false to true, then it's going to recompose. Now here we have the card with our modifier. Full max width is just going to take us full max width. You can see it's a card because of the little round corners over there. We've got 16 padding over there. It's got an elevation of 10 dp, which gives you that little shadow over there. And now here, this is interesting. We've got on click. So this card has got an on click. And what we're saying is here, if you click it, you swap the value of expanded. So if you click it, it's going to expand. And if you click it again, it's going to unexpand. Okay. Now here's our row. So this row is the row that if you look at those little boxes, there's the bunny and then there's the text on the other side. And there's our column, and the column's got the title. And now here's another thing that's interesting. We're setting the style here to be headline small. So this is part of the material theme, and you're pulling it in from your theme, and the typography is set. So this could be something else. Let's see what it could be. It could be headline large. I don't know if that's going to do anything and make it look horrible. It might. Bold refresh. Yes, is that bigger? It is bigger, I think. Let's go back to headline small. Oops, typo. Bold and refresh. Oh, more typo. Bold. Oh, yes, error. See, it's a live demo. Okay, now let's see what it does here with this. So here you can see it's got a flag. There's the flag, there's the expanded flag. And what it's doing here is it's saying that if it's expanded, show the long description, else show the short description. So let's see what that works. So if I make it go into interactive mode and I tap the card, it should tap the card. Ah, you see, it's showing me the large description. If I tap it again, it shrinks it back. And that's because the composer remembers the state here and this remember. And when the state changes, it knows that the piece that needs to be recomposed is this text at the bottom here. There's another thing that's interesting here. Let's just look at this modifier on this text. So here we've got the material theme, it's body small, which makes it small like that. Here's our modifier. So you can again see all of the composables. At every composable node, you can add a modifier. And this modifier's got padding 16. But here is quite an interesting modifier. This one says animate content size. I'm just going to comment that out. And let's just see what happens if I comment that out. Once it's finished building. Build and refresh. Okay, so if I go into interactive mode now, and I tap it, So what you see here is you can see that this text, it flashes small and big. But if I put this modifier in, it animates the size of the card depending on the content. And it kind of slowly opens it up. And the other thing I added here was, this is an animation spec here. And this just means take 1 millisecond and animate from small to big linearly over one second, 1,000 milliseconds. Did I say 1 millisecond? No, 1,000 milliseconds. So let's see if this is going to work. No, this is still the old one. Stop interactive mode. Rendering preview. Okay, interactive mode. And let's see. Okay, so you can see how it changes the size with an animation. And that's just another little sample of how easy it is to add an animation to Jetpack Compose. Okay, I can show you some more stuff. I don't know how far I am. I think I'm over time, right? So I can stop. So I won't show you the other animations. Yeah,
you do have another question.
Okay.
How many states can we ask the composer to remember in a single composable, sorry?
It can remember, I don't know what, I think it's like the memory, it's the limits of the memory, because at the moment I'm just saving one variable, but this doesn't have to be a variable. This could be a data object there. So it's the state doesn't have to be, it's not flags, it's not just a true false. So you can have as many as you want. It just depends. I think it might fill up the memory eventually. So I guess the answer is as much memory as you have. Does that make
Cool.
sense?
Makes sense to me.
Okay, I'm not going to code more. I think I'm over time already by 5 minutes. So I have more samples, but we can look at them afterwards if there's time. But I think this is enough of a kind of a feel for what the coding experience would be to write code and compose. So let's just stop share. Let me just finish my slides quick. Share screen. Share screen. Show me the code. You should see show me the code. So what are my impressions? I like that it's declarative and that makes it really easy to think about. I like that it's easy to add new composables and you use composables like the card and the text, which have really good common default values, and the common cases are very well coded up so that it's easy to add and it's easy to tweak. So it means that you can get going pretty easily, putting cards, putting buttons, and get going. And then if you get to a point where you do want to modify, you do want to add modifiers, or you want to change the style, or various different things you need to do, then it's pretty powerful in the things that you can add. And with that, there is the repo, and I will take more questions if there are now.
If you have questions, you can raise your hand or type them in.
I'm going to stop sharing, then you can see my face. Okay, should I look at chat? Do you want to tell me? Because I've got the screen share off, and do you want to read them?
Either way is fine. I think let's just read them aloud for everyone listening. For screen orientation changes, does the recomposition occur, and how is it tied to the lifecycle methods?
So yes, recomposition will happen again. It will recompose, but you can, those state variables, there's a way to save them so that you can keep the state that you had from before the rotation. So some things will adjust, obviously, because if you're rotating, then you'll get different layouts and widths. So yes, it will recompose. But the other thing to mention is, right, you're going to use compose together with view models. And that's just the same view model you had before, right? The view model is lifecycle aware. And if you're persisting things inside a view model, it's going to have the same behavior as if it were an XML, or it doesn't know if it's compose or XML. So you're going to get the same lifecycle and persistence behavior from the view model that you would have got even if you were using XML. Does that make sense?
I think so. The next question was, where should we use state variables inside composable or the view model? So I think that ties in with what you were saying.
So your business logic and your presentation layer has some state, which comes from like the backend or the APIs and so on. So those kinds of state, I would leave those inside my view model, and I would pass that state in because that's part of your app. A good place for these like remember flags are if you need a state that's really just that view, right? So the view model, that the data that comes in from the view model is maybe the card that's got the bunny and the long text and the short text, but that view model doesn't know if the actual card has got expanded or not. That flag that remembers it's just localized to that card, it's a good thing to keep inside of view. If you had a custom view or if you had something else, you would have some form of state in there. So you wouldn't use any of these mutable states in your view model. You would use your normal view model persistence of state that you had anyway. You would cache it in your database if you needed to, or have in-memory copies of whatever. And then just really those remember states are just for state that is localized to the view that you're busy working on. I hope I'm saying the right things, Thomas. I hope you're nodding. Are you nodding? He's nodding. Okay. Any more questions? Cool.
I think you just got a thank you.
Cool.
Maya, would you like to ask one of our audience members a question to see if they were paying attention?
I want to know, what do I want to know? Have I got a question? How many people are using Compose in production? How many people want to use Compose in production? And how many people hate it and don't want to use it? That's the wrong answer. You know, can't answer that one.
Fastest fingers first. Who's answering first? I see Pamela. I think Pamela was first.
Hello. Yeah, we're using Compose in production. So I work at GoDaddy Studio, and we're definitely using it in our color picker, which is also open source software. It's on Maven, and we're running it on desktop as well. So go check out our project. Shameless
Ooh.
plug.
Do you like it? Do you hate it?
Good. It's a nice change. Yeah.
Okay.
And Joshua wants to use it. And Ewald doesn't count.
Ewald never counts. Pamela, you just need to send your details through to one of the organizers. You can send it to Joshua or myself. We'll give you a little something from JetBrains as a prize. I think you were first, right? I just saw a heart pop up. Nice bright red heart from Pamela.
I saw that as well.
Okay. All right. So, yeah, thanks, Maya. I don't see any more questions. And yeah, I appreciate that. The next time I'm tempted to just hack away at XML, because that's the last time I was working with Android Studio. It was absolutely terrible trying to get anything working. I'll consider this and not go back to my old 1990s way of coding with like thinking about Notepad and old
Okay.
formats. Thanks.
You can mix and match though. You don't have to just choose one.
Yeah, there are options now. All right, so I guess we can move over to Thomas. Thomas, you can introduce yourself and go ahead.
Right, thanks very much. Hello, everyone. I think I'll start by sharing my screen. Give me a second, please. Can you now see my screen?
Can see it, yes.
Okay, perfect. So first of all, I'd like to say thanks very much to Maia for this wonderful introduction to Jetpack Compose. And actually, I'm really pleased that the live coding gods were with you today. Actually, I'm frightened of them, so I decided to cheat. So though I will be showing you quite some pieces of code today, it's not live in Android Studio because I feared my Android Studio crashing too. So I pre-recorded some clips. Nonetheless, I hope you will be enjoying what I'll be presenting to you. We've seen Jetpack Compose in action, and now I'll talk about what's new in Jetpack Compose 1.1. A couple of sentences about me. You already heard that I'm really old. I worked with computers in the 1980s, and being old probably means that one tends to forget a lot of things. And in order to not forget too many things, I decided to write them down. And in fact, I decided to write them down in some books. I've been doing 3 books in German throughout the years. And last year, I was approached by Pact Publishing. They asked me if I wanted to do a book about Jetpack Compose. And also they asked me if I wanted to do it in English. And that was a big opportunity for me. So I sat down and wrote a book in English. It's going to be published next week. So if you are interested in taking a look at the book, I'd love to hear what you think of it. So you're more than welcome to contact me via email, talk to me on Twitter. So I'd like to hear your thoughts on Jetpack Compose, even if you get your information not from my book. So now let's dive into Jetpack Compose 1.1. The first version of Jetpack Compose is almost 1 year old. The first stable version, Compose 1.0.0, appeared July 28th last year. And after that, we've seen quite a lot of versions. We got the first alpha version of Compose 1.1 in August, followed by the first beta version in October. And then we had a release candidate in December, and a couple of days ago, February 9th, Compose 1.1.0 finally became stable. If for whatever reason developers do not want to go to Compose 1.1 right now, we can still keep using Compose 1.0. There's the currently stable version is 1.0.5. So now, why am I focusing so much on version numbers? It's worth noting that, as the name implies, Jetpack Compose is part of the Jetpack component library. Jetpack is a suite of about 90 libraries that we can use in our Android apps, and Compose has been the latest edition. Actually, I think we haven't said it that clearly. Compose is set to be the new native UI toolkit for Android. I mean, we will be able to use Fuse in the future, but Google is asking us, Google is encouraging us to switch to Jetpack Compose, at least for our new apps. And even our existing apps might be migrated to Jetpack Compose. To use Jetpack Compose in our application, we need to add the libraries to our module level build.gradle file. And this is a nice thing because developers can decide to either pick or skip updates. And this decision obviously should be based on what has been changed. I will be talking about this in greater detail later. But for now, I'd like to talk a little bit about building blocks. That means of which parts Jetpack Compose consists of. First of all, we have a rather important basic layer. We have the compose.compiler package, we have the compose.foundation and compose runtime. And if we look at these pieces, the compose.compiler package contains something that is needed to actually transform composable functions to executable code. I mean, Maia has been explained this really nicely. We write composables or composable functions by annotating them with the @composable annotation. But to make this composable show anything, there needs to be a lot of work done under the hood, and an important role in achieving this is done by a compiler plugin which generates quite a lot of code under the hood. We as developers do not need to interact with this code that's created under the hood, but it's important that it's there, because otherwise Compose would not work. Then we have Compose Foundation. This package provides quite a lot of basic functionality like text and drawing primitives. And then we have the Compose runtime, which is some sort of glue layer that interacts with the code that has been created by the Compose compiler plugin and by our composables. So this is rather important basic stuff. Like I said, usually we do not need to bother too much, but it's important to know that it's there. Then we have a middle layer, we have Compose Animation, and we have Compose UI. As the name suggests, Compose Animation is responsible for showing beautiful animations. And unlike with the old Android view system, it's really easy to create animations with Jetpack Compose. It usually is just a few lines of code compared to dozens of lines of code that we needed to implement previously. Compose UI also contains things that we need to interact with the device. We also got a few of the drawing primitives here, and Compose UI handles input like touch gestures, things like that. On top of all this, we have quite a huge package that is called Compose Material, and Compose Material implements the material design components. You probably notice material design is the design language for native Android applications since 2014. Material design has seen now 3 iterations. I will turn to the latest iteration, which is called Material U, and the second half of my talk. So what's important to notice that each of these blocks I showed you on the previous slides is a separate implementation dependency that we need to include in our module level build.gradle file. Which means that I need to explicitly say, hey, I want Compose animation, and hey, I want Compose material. There's no way of saying, hey, Android Studio, just give me Compose 1.1. So there's no catch-all reference. What's also important to note, the Compose versions we choose may influence other build settings like compiler plugins or language levels. For example, earlier versions of Compose 1.0 required Kotlin 1.5, whereas the latest Compose 1.1 relies on Kotlin 1.6 features. So it may be not always trivial to decide which versions to choose in our Android projects, and we need to keep this in mind when deciding which Compose version to use. Now, if you are an seasoned Android developer, you may be thinking, well, he has been talking about Compose versions, and he also said that there are different dependencies I need to add. Isn't there something like the API level we know from the platform? I mean, when we wanted to update our apps, we needed to take into account changes that came into play with new API level, but how do we do this with Compose? Because although we say we use Compose 1.1, we cannot fix this to a certain API level because this it hasn't been implemented. And this has very significant implications. You may know what the API difference report is. This is a nice list of changes on a class and method level that lists all changes between 2 Android versions. And speaking of differences in Jetpack Compose versions, it might be really nice to have something similar for Jetpack Compose. But the sad thing, there is nothing there yet. In fact, Google maintains separate release notes for all the packages I've shown you. So to find out what's changed, you either need to read them all, you either need to read the official summary from the Android developers blog, or you need to have someone else show you what's different. And this is what I'm doing in the remaining part of this presentation. So generally speaking, Jetpack Compose 1.1 saw a lot of bug fixes. We got a lot of performance improvements. We also saw some experimental APIs becoming stable, for example, inside animations. Also, we had enhancement regarding accessibility. For example, the minimal touch areas increased. And we have quite a few new or changed composables. And now let's look at these composable functions. The first one I'd like to show you are actually 2. The first one is called a batch, and the second one is called a BatchBox. Basically, the batch contains dynamic information like the unread email notification, or hey, you've got unread messages or things like that. The batch can either be an icon or it can be an icon with some short text. And the BatchBox uses the batch and places it relative to this content, for example, text like an icon. So, and here's how this is done in code. Like I said, we have a batch. The batch consists of a text label. This text label has the word new printed, and it gets an icon. And as you can see, to show an icon using Jetpack Compose, you use the icon composable, and it receives a so-called painter. And the painter I am using here is a nice thing. It's called the painter resource. And this way we can use the icons the same way we used it in the traditional Android app, that is referring to a resource. Here in this example, I'm using a resource that is labeled IC baseline Android 24. But this is how batch and BatchBox is used. Here's brief info about the parameters. It's worth noting that Kotlin has the notion of default values. This means that you do not need to specify all parameters that are listed here. Some are optional. Some parameters that are used quite frequently in composables is the modifier. Maia has already mentioned what the modifier context is. I'll briefly explain it, but before, let's look at the parameters for the BatchBox. Obviously, it gets the batch, and the second important thing, it's the content. You may be wondering why the first parameter, batch, is mentioned explicitly, whereas the second parameter, the content, seems to be not mentioned at all. This is a nice abbreviation in Kotlin. Usually the content is passed as the last parameter, which is the curly bracket you see in line 2 to 4. So whenever we pass a content to a composable function, it's usually not mentioned immediately in the parameter list, but instead is put after the invocation of the composable and put in curly braces. Now, before I turn to the next slide, one or two sentences about the modifier thing in Compose. Maia has already explained that there is a great difference between the old Android view system, which has been called an imperative UI framework, because any change we wanted to have on the user interface needed to be programmed or implemented imperatively. I mean, any change we wanted to have, if we wanted to change the color or if we wanted to change the text, we needed to write that down implicitly, because any imperative UI framework modifies a so-called component tree. The component tree is a representation of what is seen on screen. And declarative UI frameworks like Jetpack Compose, like Flutter, and like Swift UI, they have a completely different notion. They do not maintain a component tree, but in declarative UI frameworks, what is visible on screen is declared by the user. And if a certain element is not to be shown on screen, it's simply not declared. But having no component has some implications. Usually component UI frameworks rely on hierarchy, on an inheritance hierarchy, where common features like background colors, the width or the height of a component are stored in the more general versions of the widget, whereas specifics like text or things that are not common to any component are defined in the descendants, in the children of the more common components. But this means that we cannot share common parameters or common properties because we have no inheritance in Jetpack Compose, and that's where the modifier comes in, because the modifier collects all these things you want to add to a composable. So if I want to add a background color to a composable, I add the background modifier. And if I want to make a composable clickable, I add the clickable modifier. So I deliberately choose how I want to amend a composable. And if there is no need to amend the composable, it's no need to set any property. And this is one of the great advantages of the declarative UI philosophy over the old imperative approach. Now, let's return to Compose 1.1. There has been an experimental predecessor, which was called BatchBox, mind the missing D. And here's how the old BatchBox was used. So we did not have the batch composable, but we had a batch content instead. So like I said, it was experimental, and with Compose 1.1, Google decided to streamline the API. The next thing I'd like to show you is the exposed drop-down menu and the exposed drop-down menu box. As you can see in the animation, it's a very compact form of showing some sort of pop-up. This is a very common interaction pattern, so it's good to have it in Compose applications as well. Here's how it works. Before we can actually use the exposed drop-down menu box, we need to set up a few things. Here you can see something Maia has already explained. Here we need to remember two states. One state we need to remember is a thing called expanded, which essentially says if the exposed drop-down menu is opened or closed. And the selected text is, as the name implies, is the text that has been selected. So the exposed drop-down menu box receives these two states. No, sorry, it receives one state. The first one is the expanded state, and it also receives as a click handler when the expanded state changes, something needs to be done. And in my case, I'm just inverting the state. So if the menu is open, it is closed. And if it is closed, it is opened. What's actually the content of the exposed drop-down menu box is not visible here in the slide. It's represented by the three dots. Let's take a look at it on the next slide. The first thing we need is a text field. This text field really receives the second state you saw on the previous slide. It's the selected text. This is something that is very common practice in Compose. A text field has an on value change callback. This is invoked when the user types in text. We set this text field to read only, meaning that the user cannot type anything in. So we don't need to do anything in the on value changed callback. We set a label and we set an icon. You've seen it in the animation on the previous slide. And now the thing that remains is how does the actual drop-down menu work? As you see, it receives the expanded state. And we also need to implement something that's called an on dismiss request. This means that this code is executed when the user taps outside the pop-up, which means the user wants to close it. And in this way, we just set the expanded state to false. And the content of the pop-up is easily created in this for loop. Actually, the content consists of drop-down menu items. Here's the list of the here are the parameters of the drop-down menu items. As you can see, it receives a text, which is the content, and it receives an on-click, which we use to update the text field, and we use to close the menu. The last thing I would like to show is something that's called navigation rail and the navigation rail item. As you see, the animation takes a little longer than the previous one. What you're seeing right now is the navigation rail. The navigation rail is vertically aligned navigation composable, which should be used only on foldable devices and on large screens. If the device is not folded or if the device is just a smartphone, we should not use the navigation rail, but we should use ordinary navigation bars. So this is why my sample shows how the navigation rail and the ordinary navigation bars interact. Again, here is some code. We have the navigation rail. We add a couple of so-called navigation rail items. Let's looking at the clock. I'm not sure actually how much time is left. So I'll go over the slide a little bit faster. As you can see, we can set the content, which is the most interesting part. In this case, it's an icon and a label. And a code in the on-click callback, which is executed when the user taps on one of the navigation items. So this was a quick ride through the changes in Compose 1.1. You surely recall that I said Compose Material is an implementation of material design, and I also said that material design so far has seen 3 iterations. The first iteration appeared 2014. The second iteration, which is called Material 2, appeared, I think, 2018. And the latest iteration, which is called Material 3, appeared last year. It focused on personalization. We have larger buttons, and it supports system-provided color themes. And whereas Material 3 is the name of the version of the design language, the implementation on Android 12 is Material U. So this is probably interesting to see because we will be including the Material 3 library in our Compose app, but actually we will have an implementation of Material U when we actually run our app. Visually, there has changed quite a lot, as you can see on the left-hand side. This is how Material 2 looks, whereas the right-hand side shows Compose app using Material 3. So to make our Compose apps look native to all the new fancy Google apps we see on our Android 12 devices, we should use Material 3 in our Compose apps. What's important to notice that Material 3 is not a drop-in replacement, meaning we need to change significant amounts of code. And it's also worth noting that so far Material 3 is not yet stable, although Jetpack Compose 1.1 is stable. Material 3, the implementation is not yet stable, which may mean that we need to change our code more often. In the next couple of slides, I will point you to a few of the differences between Material 2 and Material 3. These are just examples where you may need to make changes to our code. Of course, this is not a complete list of changes, but just to give you an idea what has changed and where you need to pay attention to. In Material 2, we had a thing called top app bar. It's the big bar at the top of the screen. And in Material 3, this thing changes to either a small top app bar, a medium top app bar, or big top app bar. These are the changes we saw in Material 3. Actually, we have more options to say how big the top app bar is, and this reflects in a change on the API side, because we certainly need to specify which size our app bar should be. Another change is related to bottom navigation. In Material 2, we have the bottom navigation item and the bottom navigation, whereas in Material 3, we will have a more generalized version called the navigation bar and a more generalized version called the navigation bar item. Fortunately, the parameters remain, at least as of today, remain the same. So it's a matter of simply search and replace. Nonetheless, these are changes we need to apply to our code. And the last change I would like to show you is something we have seen in Maia's code. We can style our apps using attributes that come from the material theme class. To access colors, we used to use colors in Material 3, whereas in Material 2, whereas in Material 3, we need to use a color scheme instead. And also the attributes of the color scheme have changed. For example, in the old version, we had a surface, whereas in the new version, we have, for example, a surface variant. And what has also changed is the way we describe font properties. In the old version, we used to say typography.h3, which resembled the tags we know from HTML, whereas in Material 3, we now says typography.headline large. Like I said, these are breaking changes, which means that if in your app you want to switch from Material 2 to Material 3, you need to change these, otherwise your app won't work. It won't compile. Now, this has been quite a fast ride, so it's time to wrap up a few things. Compose 1.1 is a minor update, which includes welcome bug fixes. We've seen quite a lot of performance improvements, and fortunately, only a few API changes. So the move from Compose 1.1 to 1.0 to 1.1 should be easy. Material 3 is not directly related to Compose 1.1. If we want to incorporate this into our apps, we will be facing breaking changes. And also, please keep in mind that the API is still experimental. On the other hand, with Material 12 gaining momentum, we probably need to update our Compose apps sooner than later, because if we don't, the apps won't look great compared to all the other apps that already switched to Material U. There are some drawbacks, like all Jetpack components. Jetpack Compose has quite short release cycles, which means we can benefit quickly from bug fixes and new features, but it can also mean that we may be forced to frequently update our code. And we as a developer, we need to balance between staying up to date with the latest API and keeping the amount of changes to a manageable amount. So that's it. I hope you enjoyed this brief introduction to Jetpack Compose. Like I said, I'm more than happy to discuss Compose with you. Please feel free to contact me via the social media channels, and otherwise, thanks very much for listening.
Well, thanks a lot, Thomas. I think between you and Maia, I fully understand why we need a panel discussion after this. Wow, it's a lot of information to take in, but it was great. Just one more thing, Thomas, would you... Okay, so if you can stop sharing,
yeah,
we're going to have another one of those questions coming up where Thomas will ask you something, and fastest fingers first. I'll try to look for the first person that pops up. Maia and Thomas, if you can help me with that. But Thomas, any questions that you might have?
Actually, one nice question would be, when was the Compose 1.0 version final? At which date?
Anybody? November 2021 from this orator. I see 1 July 2021.
Yes.
What
Yes.
is the correct?
Yes, July
is
28th
July?
is the correct one. Yeah.
July 28th. So that is from, I hope I'm pronouncing your name correctly, Ewan Scott. Is that right? I've just allowed everybody to unmute and show their video. So if you'd like to show your face or not, is that right, Ewan Scott?
Yeah, someone gave the full date, right? So there's 28 July 2021. I don't know how you're going to choose the right answer, Thomas. You have to choose.
There's 28th July and 28th July 2021. Yeah. We probably need the date, the year as well. What was the year?
Last year. 21.
Sorry, Ewan Scott. I think it actually goes to Windenoda, Washaya. You still over here? Yes. Okay, if you could send a message through. Oh, good sport. If you could send a message through to either myself or Ewald, because I see Ewald put his pretty face up as well. You can direct message us just with your email address, and we'll make sure that you can get your Jetpack Brains prize as well. Yeah, any other questions for Thomas? Anything you might need to ask about this specifically, or we can go straight to a little panel discussion. Maybe Thomas and Maia, you'd be able to tell us a little bit more in your own experience. But before that, let's just wait a few seconds. Still no questions, right? Before that, I promised you some swag. So those of you that have waited until now, Offerzen has a survey where you'll be able to get yourself one of the pretty cool t-shirts. I've gotten a few myself, often with dinosaurs and all sorts of things. They just want you to fill in a type form survey. Very non-intrusive. I've just shared the link now. They'll ask you a few questions. It will take about 2 minutes of your time, and you can choose to opt in or not to opt in to emails and other special offers that they might have. In addition to that, go ahead and fill in that survey. It's free. They give it to you for free. You can opt out of all communication afterwards. Take it or leave it. Offerzen has also asked that we can share the State of the South African Developer Nation 2022 report with you. So that will basically just tell you where you stand if you're a software developer. In terms of salary, they have interesting things such as the gender gap, which is a real thing. Men versus women's pay is quite different, along with the same experience and similar jobs. So it's something interesting to look at if you're interested in that sort of thing. Yeah, let's run straight through to the panel discussion then. You know, Ewald always has the best questions. Anything? Kick us off, Ewald.
May I?
Oh yes, please.
All right. So this is for both the experts. Looking at from the time where Kotlin came into play in the Android space, and then looking at all the wonderful things that has happened, especially with Compose, what are your predictions for the next year or two? I won't make it 5 years. For the next year or two. So Maia, you seem like you've got a lot to say. Why don't you go first?
I would rather say, I'm not going to answer your question. I'm not going to predict. I'm going to rather say what I wish we could get, right? How does that sound? So I'm wishing that we get better previews that don't crash. With quicker updates for Compose. I'm wishing for, let's see, I'm also wishing that Bumblebee doesn't make the network, there's a network inspector and that's crashing at the moment. So I'm wishing that will stop crashing. Let's see if I can think of some other things to wish for. I'm wishing for more better tools that designers can just like design, say in Figma what they want. And then I know there was some speak about it, but to have those things improved so that they could just design and then export, and then we'll get like code templates that we can just pull straight from Figma. Yeah, I think that's enough things to wish for.
Awesome, thanks, Thomas.
Actually, I think I'll pick up on this. I would wish for some sort of consolidation. I mean, the Android ecosystem has always been really fast-paced. Maia, you surely agree. It takes a lot to stay up to date, and we see so many things in quite a short period of time. And while it's exciting to see all these changes, we as developers need some time to take a breath and really appreciate the things that are new, and we need time to adapt to these new things. And frankly, I would wish that now that Compose is final, we get this time to really acquaint ourselves to the new technologies. I mean, a lot of us have been doing Android applications for more than 5 years, and we are used to the old view system. And frankly, there are a lot of different concepts, and we need to fully grasp these new concepts to use Compose properly and to use it right. And this takes time. And I would hope that Google gives us the time to really let things settle. And yes, to make things stable. The way Android Studio has developed is really great in itself, but currently things are not as smooth as we would wish them to be. And why not, before adding new features, why not taking some time to smoothen out the sharp edges? I would really wish that we get a version of Android Studio that is fast. I mean, if you're on Twitter, we all see these jokes that Android Studio takes the latest hardware and makes it slow and things like that. And this is sad, because Android Studio is a wonderful, a beautiful tool, but right now it has not the best perception, and this should change, that we can fully appreciate it again.
Awesome, thanks.
I just thought of another thing I want. I want the way that you update Gradle libraries to be something that's more like the package. You know, in Linux, you can go sudo apt-get blah, and then it will find all the pieces that it needs. Now, I wanted, if you like change, if you need to get, say, compose 1.1, that there's a way in the Gradle file that you can do that you can just like, in a wizard way, say, okay, I'm updating this, and that it will like automatically find the right things it needs to. I know the way that the libraries are structured, it makes that possible, because with Maven it can pull things, but I still find I spend way too much time updating old apps, trying to get all the libraries to be exactly the right version.
It's a little bit easier in Gradle, I find. Yeah, it just feels like it's simpler and easier in Gradle, especially with when you've converted to the Kotlin DSL build files. Then the code completion stuff just makes your life a lot simpler. But yeah, I mean, there's a lot of projects that run on Maven as well for good reason. So it would be nice if the tooling can catch up and just make our lives a lot easier.
I mean, in Gradle, you can go Alt, Enter, or whatever, and then update to the latest version, but you still roll a dice and break your app sometimes, right?
That's QA's problem.
Now, what can be difficult for developers is to find the more subtle dependencies. I mean, it's easy to say, okay, I have decided to switch from Compose 1.0 to 1.1, but then I need to take into account that I need to update the Kotlin language level, because if I don't do it, yes, I'll see the error message in the Gradle output file, but cycle is not as smooth as it could or should be, probably.
Yeah, that's true. That's true. Ezra, if there are any questions that people have, they can throw it in, right?
Yeah, I see. Con Mombo. There we go. So you see, so also put his video on. Great. Con Mombo is saying between the refresh versions plugin and Gradle 7's version, catalog feature, maybe we'll one day have a fun library update experience.
Oh yeah, totally. It's gotten better. I mean, it's not as bad as it was. You have tools that help you, but it's still not a slick experience. It's still not a simple, straightforward experience.
Yeah, I tried putting the catalog thing in, and it made all my build files go red. I had it in as KTS, as Kotlin files in my build files, and I thought, oh yes, let me try this. The cool kids are doing this, put the catalog thing in. And it was just like, oh, red everywhere. So it's not quite there yet.
Yeah. If there's no other questions, I have something that I've noticed, and I just want to hear if you've had the same experience. I'm fortunate enough that I get to work with a lot of newer Android developers, people that have started in Kotlin, for example, that don't even know that Java exists. And I found that in the beginning, it takes them a little bit longer to get going with Compose than if they had used a more traditional XML layout. But the moment they have momentum, it just rockets, and they start doing stuff that I wouldn't even have tried in the old XML layouts that they do in Compose, and they do amazing things in Compose. Is that a general thing? I mean, is that just because I'm a phenomenal teacher, or is that because the tools are so cool? Has anybody else noticed this?
I think it's just you, Eva.
Probably.
Yeah, I can comment on that from the perspective of the animations. I mean, we're not using Compose in production yet. So when I was exploring the animations, I built a little app to see if I could just get something and try it. And I personally experienced that sort of initial slow because my head was still building view models in like hierarchies. But the minute I got over that and I got the hang of it, I could then quite quickly do it. And now you can quite quickly just like say a word, turn it into a composable and try things out. And then on top of that, the animations, because they're built into the way Compose works, and they work with that state system, it's like a no-brainer to just make something just animate or change or modify shape or whatever. Whereas with the view system, I would always like hesitate and kick my heels in, and then the designers come and show me this cute animation, and then I'll say, yeah, that's really cute. I'll do that next sprint and then hope they forget, right? But with Compose, I can put in animations up front and then just get the designers to say how they want it different.
Absolutely, yeah. I like that actually, because it does enable you it gives you the freedom to experiment more and try things, because it's not going to be a complete smash up. Yeah, really cool.
Actually, I experienced what you've been saying, Eva. I experienced myself. I first had to digest this cultural shock coming from the imperative world. I mean, I've been doing Java Swing applications in the early 2000s, and this was to achieve anything, you had to write dozens of lines of codes, and in the end, sorry, dear Swing fans, the app would not look great. How hard you tried, and to move away from that old world thinking in components and thinking in pure functions was a great step for me, probably because I've been in the old world too long. But once I made that step, once I appeared in the declarative world, it was that, oh my God, how easy can it be to achieve things? Just like you said, Maia, if you compare how easy it is to do animations in Compose, or how easy it is to populate a scrollable list in Compose, and if you try to remember how we did it once with a view, the difference is so huge that it's wow. So yes, we get a lot of productivity, and we get a lot of creativity using Compose, I think.
Totally. But that leads me to something else. with the fact that we are so productive and we can do so much more, that's got a massive impact on QA, because we are just churning out a lot more stuff. How do you feel about the testing tools available for Compose at the moment? I'm underwhelmed. I don't know if it's just because I don't understand everything, but I feel like there's a lot of friction there to get slick tests up and running, especially automated tests. I don't know if you two have played with that at all.
I was going to do it next sprint.
Always next sprint.
I mean, to be honest, doing automated UI tests has not worked very good, no matter which platform you look at and no matter which time you look at. So actually, I refused to do automated UI tests unless I was forced physically to do so. And regarding Compose, we need to keep in mind that there is a shift, a switch in what we want to test. While I've been writing the chapter about tests for the Compose book, I had a few interesting discussions on Twitter, because I had an example which basically checked that the background color of some composable was green. And I said, hey, it's difficult to do that in Compose. And someone from Google said, yes, you're right, it's difficult to do it this way, but why are you testing that the color of the composable is green? Why don't you check that the state that stores the color contains green? So it's a change how tests are written and what actually we test change, because again, coming from the old imperative world, we needed to check that our component had the right property. But now we no longer have properties. And so what we use to test on a UI level probably no longer needs to be tested on a UI level at all. And this is something we as developers need to keep in mind or acquaint ourselves to.
That's a very good point. I mean, I'm conscious of that we need to change how we test and what we test. At the same time, though, I've done a lot of work in other frameworks like Flutter and React and stuff like that as well. We test the state, it looks great, but the UI still looks messed up. Yeah. So you know, there are scenarios where there's bugs in the framework, or the framework just does something weird, or the device does something weird. So there's this balance we need to find between that. But it's a very good point. We do need to address how we test, because how we develop has changed so much.
I mean, so in an ideal world, what I think could work really well is if you have like a module with all of your composables in, with all your little buttons and animatable things, whatever, and you can build a little showcase app that's got none of your business logic in it, but that just has an example of all of your UI. And you can give that app to your designer, and the designer can literally, without automating, go through everything and say, oh, but these corners aren't right, or this color is wrong, or whatever. And you can polish those components really, really, really carefully. And then just pull that module into your app, and then still have your view models with your business logic and your repositories, and do unit tests on those. And those run in Java and those run quickly. So you know that the visuals are going to be right. You know that the state is going to be right. And because the state is not mutating as you pass the state into the composables, you can state for in your little showcase app, you can state so that the designer can see like a test. So having those tests, what you would then need is a few golden loop kind of end-to-end tests, just to make sure that those work through, and then just people doing penetration testing, security testing, like. But anyway, that's my big.
No, that's cool.
Essay on what I think about testing.
That's actually awesome, because you can do that now. You can have all your components on a couple of screens, and there you go. And if they get Compose for web to behave properly, you can even throw that on a web page eventually and have render parity, like you have with Flutter. So I'm looking forward to them doing that with Compose, because then we can write amazing web apps without understanding anything about the web, which is my ultimate goal. Are there no questions from the audience?
I don't know, I saw Sibusiso put his video on for a few seconds, unmuted, and then went away again. Did you have something to say, maybe? I can't hear you. It looks like you definitely have something to say, but your mic doesn't want us to hear you. You could also maybe type it out, or read it out aloud for you. When do you think we'll see the shift from XML to Compose? I wanted to ask for new programmers, Android. I wanted to ask because for new programmers, Android Studio is such a frustration. Is that correct? I remember when I was using Android Studio back in, what was this, 2018 or 19? Terrible.
Those are good questions. I mean, when you think we'll see the shift from XML to Compose, I think it's already happening.
Yeah.
As people adopt Compose, especially with all the new features coming out, I think it's definitely happening. It's not a case of, I think that you should adopt Compose just because. I think there should be a use case for it, because just going in to change UIs that are perfectly working just for changing it, I don't think that's a healthy approach. But we are seeing in what I'm seeing, at least in production, is apps that still use XML and newer features are built in Compose. I don't know what you two are observing.
Yeah, so the thing I think what's going to happen is it's going to be like the shift to Kotlin, where the interoperability is so good that you can have things both ways. And then your people are going to say, okay, well, we're not going to use Kotlin. We're going to carry on using Java. You can only use Kotlin in some small places. And so you'll find little components creeping in that are Compose. And then people are going to go and they're going to need to work on them. And they're going to hate working on the XML. And then they're going to start converting the XML to Compose. Either that, or the designers are going to see the new Compose icon or a Compose thing. And they're going to say, okay, do that on this other screen. And then you're going to say, okay, I need to convert to, and then slowly but surely, people are just going to start converting.
Completely agree.
Sibusiso also said, sorry, Gradle always breaks example applications and also libraries are always deprecated before you know it. For somebody new, how does one keep up to date? I think Sibusiso doesn't want to be left behind and just abandon it like I did.
That is a massive challenge, and it's a side effect of the fact that Android is moving so fast. So often by the time you see an example, it's 6 months old, or 8 months old, and it's two or three Gradle point releases behind, and something has changed and something has been deprecated. That is a massive pain. I don't have a simple answer for that. What I do is I go and check, when I check out a project, I go and check and make sure I've got that version of Gradle that it uses installed. I've got that Android SDK installed, so that I can use the exact same tooling that the author used. That's the only way I've found to reliably load examples. And even then, so depending on how the Gradle files were set up, it might be pulling in a dependency that's too new, and then you have to go back a little bit. So, that is a massive frustration. And I don't know, any tips from the smart people on the panel?
There's no silver bullet to it. We have a way too tight dependency between Android Studio versions, Gradle, included libraries. This is something in essence only Google could fix. We need to break that tight dependencies, and the way your approach is the most reasonable and the most sensible thing to do. That, like I said, there's no no general answer. The only thing you can try is to not update it all, but this won't save you, because at some point in time you must update. So that's what I tried to express on one of my slides. There is an interesting thing. When do I update my libraries? What is the right time to have as less pain as possible? Because if you update too often, you need to pull in library versions that are not yet stable. And if you update not often enough, you need to apply too many changes, because the API may have changed not once, not twice, but 3 times or even more. So this is really one of the things that are, sorry, I have to say, these are the things that are not too good on Android, because sometimes the release cycles are just too fast.
Totally. I do like Maia's suggestion of building from the command line. I'm a big Bitrise fan. I've got a Bitrise Docker image that's very stable that I use to do all my builds and things. And yeah, unlike Android Studio, it doesn't try to change and upgrade everything all the time. You know, every 3 seconds is a new this or a new that. So yeah, I'd like that. A CLI build. It's also a good experience, actually, to be able to build from the command line. I'm always shocked when I work with people that have just never built from the command line at all. And then when we want to set up a CI/CD server, they're completely lost because they've never typed the Gradle command in their life, which is weird.
Another question from Sibusiso. When do you think Android will have a package manager like Maia said? Then you could control the Gradle package or the environment variables, for example, application.
So there's your ticket to fame, Sibusiso. Write us one. You've identified a need in the market. Write us one, please. We're waiting.
So Sibusiso, you've been really chatty, even though you aren't able to speak. How would you like a JetBrains voucher, so you'll be able to get some software from them? I believe there's a plugin for what's it called, Jetpack Compose as well, which you could use. So you'll have a year-long license that you could play around, write that package manager for us.
Yes,
And
you could build it in Kotlin.
Pop me your email address to this, private message me, and we'll send you your voucher.
I want to hear what Thomas has to say about when are we gonna adopt Compose, or how does Compose adoption going to be? Because I think we never gave him a chance.
I think the more complex or the longer an app has been in the market, the more difficult it may be to adopt Compose on a larger scale. I mean, the first thing we need to look at is at the overall app architecture. I mean, to successfully migrate a non-trivial app to Compose means that the code needs to be in quite good shape. We need to have view models. We need to have view models used the right way. We ideally have the app use other aspects of the architecture components. So when my clients ask me, hey, should we switch to Compose, I generally suggest to closely look at the app from a general point of view. Is the structure up to date? Do we see weird runtime behavior? I've been doing an article for a German magazine, and I said, if we have an app that has issues updating its UI, don't even try migrating to Compose, because as long as you haven't fixed these interactions, these dependencies between the data layer and the UI, you won't end up happily when trying to adopt the new mechanisms of Compose. So I think the smaller the app is, the more easier it will be to migrate to Compose. And like Google says, new apps probably can use Compose out of the box. So Compose, I think Compose is gaining momentum through new apps. I mean, we are all facing the situation that apps are not maintained but written again from scratch. In these scenarios, it is easy to adopt Compose. But if we have larger apps that have been in the market for quite a while, I think adoption will take longer, and probably the teams will need to do quite a bit of tidying up the code and possibly updating dependencies to other architecture components, libraries, and things like that. And so longer running apps, I would see probably we won't see complete adoption at all, but like you said, Maia, small parts of the apps can be changed to Compose rather easily. And this is where Compose will sneak in, I think.
Yeah, Maia makes a great point there, which it says also if the app uses non-standard styles and themes and weird color usages. I had a scenario now recently. I'm working for a client, and they wanted to create a white labeled application, and the designers came up with something really awesome. And I looked at it and said, okay, I can do it in 6 months in XML. I can do it in 2 months in Compose. You guys pick, you know, just pick how much money you want to spend on this. And that kind of thing, because it was weird styles and color usages, and we needed to be able to switch things at runtime and everything. And we all know that themes are great, but when you've got themes that dynamically pull colors from servers and change backgrounds and things, it becomes really challenging to do. Whereas in Compose, it's easier. I'm not going to say it's easy, but it's easier to do that kind of stuff, and you can do a lot more and get so much closer to what the designers had envisioned than you could with you could previously with XML and a lot of effort. So I think the scenarios are going to start driving it, and I think as designers start to realize that there are actually ways to implement things the way that they want it to look, they're also going to start pushing for Compose to say, listen, we know this is possible. We know the technology is there. You can use it. Go ahead and do so.
It's great that you have mentioned the resources and the traditional styles, because there may be some dependencies to other libraries and to other components we may not have on our agenda. For example, I've been doing a talk about other Jetpack libraries, and one of these rather new Jetpack libraries is called Jetpack Splash Screen, which actually re-implements the Android 12 native splash screen feature to all the platform versions. And actually they are using resources to specify the icon file, and you can also use the resources to specify app colors. And merging this with a new theme-based approach of Compose may be a little more difficult or less obvious than it seems, because we need to be aware that hey, I have a wonderful way of defining themes in Compose, but there may be ties to the old world we are not immediately aware of. And this is something you had the question of what will Android be in 5 years. I think this is something where Google may need to do a little more cleanup. I'm not sure if there are any more ropes we need to cut to the old world. I mean, yes, we can do wonderful applications using Compose, but a lot of things we still need to do come from the old world. If you look at all the callbacks and methods and functions from the activities, a lot of these mechanisms rely on the old XML stuff, and maybe we need to do some of these things from scratch to really fit into Compose. We had this orientation change question where someone is the Compose app recomposed if the user rotates the device. This relates to the life cycle of applications where they may not be optimal for Compose, and you find some suggestions on Twitter saying, you can override certain manifest attributes to get this or that behavior, and this makes the overall development possibly a little more complicated than it should be. And there Google may need to streamline a few things to make it easier for developers.
Those are really great points. I think, Maia, you probably have quite a bit to add to that.
Yeah, I think we're going to have a sort of like a Frankenstein's monster style approach for a bit still. And then, I mean, I like it that the things change so quickly, even though we have all of these problems with getting our libraries right. I'd rather have them change quickly and then people fix the bugs. And okay, yes, I do get frustrated, but we just need better tooling around that. And as far as the themes are concerned, I was just doing an experiment where I was trying to put Compose into an open source app that I know. And the theming, yes, there's an interoperability where you can say, I use the old theme and then I can convert it with that MDC converter thing to the new theme. But if the old theme is not a material theme, if the old theme is like using some materials, but it's got so many custom attributes, I was not able to convert those custom attributes. I had to rewrite the theme anyway. And then the minute you start doing that, you have this strange two sources of truth, right? You have some colors in the theme on this one, and then some other colors here, and some colors are in a style, and some colors are not in the style, but they're in the theme, but the theme doesn't use it. And so they say they use typography, but they change the font over here. So like that whole thing, it can be a huge, big, complex. It sounds like a simple thing, but it can be like really complicated to do.
No, it definitely can be quite a journey, but I do feel though that it's worth going through that effort, because once you've gone through that effort once, you have something that's a lot more maintainable and a lot more easy to adapt.
Yes, but I would, in this case, the same advice that Thomas says, look at the architecture. I would also say, look at how you're using your colors and your themes and your styles, because if you haven't cleaned that up, you're going to go crazy trying to just build exactly that in Compose. If you're trying to just copy what you've got and put it in Compose, you're going to need to do some cleanup on the theme side and on the style side.
Absolutely. It's always a good time to go and see, what can we make better.
Yeah, but people want the new features, right? They don't want you to spend time on tech debt.
I just hide it in there. I don't specify it. I just go like, yeah, no, really, it's going to take me 3 days to build this button.
So a lot of people have dropped off already. I guess we can pretty much call it B. Yeah, this was nice. I enjoyed the panel discussion. It was a lot of fun. This will be available on YouTube, Developer User Group YouTube channel. Probably in about a week or two, or as soon as I can get it off the cloud. And I'll definitely share it with both you, Thomas, and Maia. And you can point people at it. Yeah, thanks a lot for speaking today. Thank you to everyone that's still here. People that have already left as well. And Thomas and Maia, you're also welcome to grab your offers in swag. The links are over there as well. Grab yourself a t-shirt, why not? Yeah. Thank you, everybody, and
awesome.
Have a really good night.
Thanks, Ezra. You did a great job again.
Bye. Bye.